Hello, everyone. We are going to express how to structure Go code in a clean architecture way. Clean architecture is a great idea. Come from uh, Robert Martin, so-called Uncle Rob, Uncle Bob. His name is Robert Martin, and there are a lot of language try to implement this great code structuring way. So today we are going to try it in a golang. Okay, so I have already created a demo project here. You can clone it before starting the uh, explanation. So I'm going to quickly go to the project. uh, let's take a brief idea what is clean architecture. Clean architecture actually inspired from onion architecture, which means we are going to split the code into separate package, separate module, and we are going to strict in how to uh, dependencies for flow works. So let's take a look at that explanation diagram. In the most outer layer of that diagram reside dedicated for external interfaces like DB, UI, web. In the arrows, take a look at that. These are pointed from outside to inside. This is how dependencies flow in clean architecture project. So most outer layer called to its inside layer, which is here control layer. Some project project it will named may be different like service layer. Anyway, most outer layer will call into the its next layer. The controller layer will never call to the outer layer, which is external interface layer. So likewise, the next layer is use case layer. Use case layer will not call controller or external interface layer, but external interface layer and controller layer can call use case. The most inside layer, entity layer. So entity layer will not call any layer because all other layers are outside from it, and external interface and control and use case can call call to the entity layer when they are necessary. So mostly I wanted to point out is the dependency flow works from outside to inside. So why we are maintaining this strict rule? Because think we are going to change our DB dependencies from MySQL to MongoDB. So only place we because the interface layer, the other layers, how inside the interface layer doesn't depend on the uh, most of the layer, which is in this case internal interface layer. The code inside the other layers will not change once we change the most outside layer. The same rule apply to the other layers also. When we are changing something in the controller layer, we may have to change in external interface and controller layers code, but not definitely in use case and entity layer. In that way, we can easily introduce a new change in the code base, introduce a new feature into the code base with the minimal code change. This is the most attractive feature in clean architecture. We in the code we arrange in clean architecture way. So that's the brief introduction in clean architecture. Let's look at the our implementation, how it arrange. uh, I have put in a new image in the code base. You can open it. In our code base most outer layer, the we are called it interface layer, and it contain HTTP, DB, and Kafka. Actually, here I have direct implementation of HTTP and test implementation DB, not in Kafka. Once I explain the code, I will point out those points also. And second layer, here I have name it as service layer. In the our diagram, it as name is controller. Dependencies work as explained before. HTTP layer will call to service, use case, and domain, but the internal layers will not call to HTTP layer. And the second layer is service, and third use case and domain. So domain layer is the most isolated one. It will not call any other layer because all other layers are outside from domain layer. Uh, all, all all other layer will call to the domain layer. In that case, we are using normally domain layer to define most generic structures and interface. Mostly structures and interface, not function. Real implementation, not function, because yeah. And let's quickly go to the code base. So I'm going to start from most outside layer, which is interface. uh, in the interface I have defined HTTP interface layer. I have split into the separate modules package, actually HTTP, Kafka, and repository. I have implemented HTTP layer here, and also I have divided HTTP also into two package, inbound and outbound. Our application do not going to call outside, so no implementation in outbound layer, only inbound is defined, so others can call in our application. So let's check our inbound layer code. Is uh, is implement simple HTTP server in golang and expose to endpoint, save student and get all student, and it's going to run in 8080 port. So that's the implementation in interface HTTP inbound layer. So there's no implementation for Kafka. Let's take a look at repository implementation. I have uh, created Mongo package, MySQL package, but no implementation. Actually, I have defined here. But in the test MySQL, I have implemented test MySQL package. In there, uh, test fetch repo has a type fetch repo struct, and it has a get all student method. And test registry also contain test repo struct, and it has three method implemented. And mostly I wanted to point out that binding.go file. Here I have export three global variable: MySQL registry repo, MySQL fetch repo, and Kafka producer. Actually, no actual implementation for Kafka producer here. Uh, Take a look at MySQL registry repo. For the MySQL registry repo global variable, I have inject test implementation here, because I am not going to call actual DB here. Uh, I'm going to demonstrate the testing here. So I have inject the testing implementation here to MySQL registry repo. When we are going to uh, run actual code, we have to inject actual implementation here. So that way, this is somewhat pattern we are using in go to testing code. When we are testing some code snipped, we don't want to call actual db. Instead we are pointing, so that case we are pointing test implementation for repository layer. Likewise I have done here. So when we are done with testing, when we are going to run actual code, we can point the real implementation here. So that's how binding works here. So that's the everything about interface layer. uh, then the next layer is service layer. Once we are done with interface layer, we are going to pass the call into the service layer. That's what we are done it here. Let's go there. In the service layer, service package, in service layer, we are going to call several use case layer functions, and once done it, we are returning the response into the interface layer back. So here I am going to call uh, use case layer here. So one thing I want to point out here is, before calling to uh, repository layer, we have to inject the dependencies in the repository layer. Here, use case layer. There's a struct called rest student. We are going to call it, and it has a dependency called repo. Its type is domain registry. Its type defining domain. So here, before calling to use case layer, we are injecting the actual implementation of uh, domain.registry type. So which is we have exposed in binding file before. So I have pointed it here. So that's how we are solving dependencies here. Once we are inject the dependencies, we can directly call repository layer. So in the repository layer, uh, as I explained before, it's depend on is inside layer, which is domain layer. But if we call the domain layer function, let's take a look at domain layer function. Is just an interface. If we call the just interface, it will return nil point exception. So avoid this. We have before calling use case layer, we have to resolve the dependencies here in the service layer, as I explained before. So that's how dependency flow works in clean now tech implementation. So the same thing happen in get all students also. We are injecting dependencies here. So let's quickly run the project and take a look at how it works. Okay. Okay, application is running. I'm going to save student code successfully saved. Let's save another entity here. It also saved, and then call the get our student implementation. It's returning the our saved value. The running code is a very simple thing. I want to point here is how to implement that clean code in Golang.